All right, in this video, we're going to go over investigation 4.1 from the second chapter. So the first section is just going to be a quick review of exponents. So before we review exponents, let's review multiplication. So one way to show repeated addition is by writing a multiplication problem. So for example, 5 plus 5 plus 5 can be written as 5 times 3. Notice that there are 4 of these 7s being added. I can write that as 7 times 4. Notice that there are 2 of these 15s being added. I can write that as 15 times 2. And if there's just one 12, I can write that as 12 times 1. So the same idea can be applied to repeated multiplication. So here we have 5 times 5 times 5. So what is 5 times 5 times 5? So 5 times 5 is 25. Times another 5 is 125. So how can I shorthand? So notice there's a lot of typing here. What's a shorthand for writing these repeated multiplication problems? So here, can we type the following? I'm going to type 5. Then I click on the exponent button, which is going to be AB to the third power. And notice that these both have the same answer. 5 times 5 times 5 is the same as 5 to the third power. Right? So this is called an exponential expression, which is made up of two parts. The number on the bottom is called the base. That's the number that's being multiplied over and over. And the upper number in the upper right-hand corner, that's called the exponent. And that's the number that we're going to multiply, or that's going to tell us what we're going to multiply over and over again. So for example here, 4 is the base, the number on the bottom. 3 is the number on top. 6 is the base. 8 is the exponent. And 12 is the base, and 4 is the exponent. So how can we write this as an exponent expression? So notice there is a 5, so 5 is my base. And since there are 3 of them, I'm going to add an exponent 3. Okay. Here, my 7 is being multiplied over and over again, so 7 is my base. And since there's 4 of them, I'm going to use exponent 4. All right, here is 15, 2 times, so 15 exponent 2. And since there's only 112, it will be 12 exponent 1. Okay. For this last part, let's go ahead and go backwards. So here we have our exponent expression. So I'm going to write this as a repeated multiplication problem. So I'm starting with 2, and there's going to be 5 of them. All right, here's going to be 8 and 6 of them. Here's 20, 3 times, 2, 3. And then 9 to the 4th power, repeated multiplication, 9 times 9 times 9 times 9. All right, so on to the main lesson. Now we're going to go over order of operations. So what order should we perform operations with integers? Okay. So in this game, we can have 4 numbers, and we can do anything we want to them. We can either add, subtract, multiply, divide, or use exponents. So just any example, I could do negative 25 times 2 divided by negative 3 plus 3. Or I can do negative 25 to the 2nd power times negative 3 times 3. So I can do anything I want with these numbers as long as I use one of these operations. So 2 people who played this game are going to be Jamar and Elena. So Jamar got these 4 cards, so he needs to write a math sentence combining those 4 numbers together. Jamar thinks that he writes this math sentence, we get 41. And Elena thinks that the answer should be 26. So who's correct? So one way of checking is by copying and pasting this into the answer, the calculator. So let's copy and paste. And it turns out if I do all of this, the answer should be 26. So Elena is correct. Using a calculator, Elena is correct. All right, the answer is 26. Oops, misspelled calculator. Okay. So how did Jamar come up with the wrong answer of 41? So let's try to think about what Jamar did. So maybe he thought of doing this part first. Quick reminder, we're going to have a minus minus. We can turn that to a plus. So let's work from this from left to right. 5 plus 6, again, minus minus turns into a plus. 5 plus 6. Again, I like to copy and paste this. Control C, Control V. I like to copy and paste it. And I'm going to change this into 5 plus 6 is 11. Okay. From here, Jamar probably did the next step, 11 times 4. Again, I like to copy and paste the previous row, Control C, Control V, copy and paste. All right, 11 times 4 becomes 44. So notice that becomes 44. And 44 yellows and 3 reds, those are going to cancel out to get 41. Okay, so this is how Jamar came up with the wrong answer. It looks like he just did everything from left to right. So he did everything from left to right and got the wrong answer of 41. But what's the correct answer? Remember, the correct answer was supposed to be 26. So let's see how Elena came up with the correct answer. Elena started by multiplying these first. So Elena started here. Negative 6 times 4 is going to be negative 24. I'm going to copy and paste. And these two parts I'm going to delete, and that's going to become negative 24. From there, we can go from left to right. Remember that minus minus turns into a plus. 5 minus negative 24. That's the same as 5 plus 24. 5 plus 24. So that part becomes, again, I'm just going to copy and paste the next row. This is going to be 29. And 29 cancel out with negative 3. That's going to be 26. So that's how Elena came up with the right answer. So one thing I want you guys to notice from this first example is that if we do math in a different order, we should get a different answer. So again, whether I do it from left to right or if I did the multiplication first, notice that these two different ways of solving came up with two different answers. So let's try another one. Let's go and see if we can solve this here. So first we're going to try doing the exponent. So remember, we just reviewed the exponent. 5 to the tiny 2 means 5 times itself, 5 times 5. So this becomes 5 times 5 is 25. Next, we're going to do the subtraction. So remember that minus minus turns into a plus. So this is negative 3 plus 6. Negative 3 plus 6. So negative 3 is 3 reds. All right, plus 6 is 6 positives. 3, 4, 5, and 6. Sorry about that. And notice that they're going to cancel out, right? Cancel, leaving me with positive 3. So 3 plus 25. And 3 plus 25 is 28. So again, if we do things in a different order, we should always get a different answer. So since we're able to get different answers, what's the correct way of figuring out what to do? So let's go and see some examples where we do things in different order. So first, let's try adding the numbers first. So let's start by adding 4. So 4 plus, let's delete that. So let's do 4 plus 3 is 7. And then 7 times 2 is 14. And if I try multiplying first, let's try multiplying first. So again, I'm going to start over here on the right. 3 times 2 is 6. And then 6 plus 4 is 10. So notice that if I do things in a different order, when I solve in a different order, I get different answers. Okay. Let's try these two problems and let's do it in a different way. So let's try by subtracting first. 5 minus 4 is 1. And then 1 cut in half is going to be 0.5. Or if I try dividing first, again, I'm going to start on the right side. 4 divided by 2 is 2. And then 5 minus 2 is 3. So again, are the results the same or different? So again, if I do things in a different order, notice that we get two different answers. 0.5 is different from 3. So again, long time ago, people agreed on some rules that we can follow. That way we can always get the same answers, even if you have a complicated problem like this. So the rule starts off as we always do the parentheses first, P, parentheses first. So here, again, I'm going to do the parentheses first. 5 plus 3 is 8. And then 8 times 4 is 32. Again, if I tried multiplying first, if I tried 4 times 5 first, that's 20 plus 3. And notice that the answer is going to be different. So again, I always want to do the parentheses first because if I don't, I'm going to get a different answer. All right, next let's try doing the exponents. Again, we just reviewed exponents a little bit at the beginning. So here we're going to do the exponent first. 2 to the second power, that's 2 times itself, which is going to be 5 times 4. And then 5 times 4 is 20. If I try doing this in a different order, if I try doing 5 times 2 first, 5 times 2 is 10 to the second power. And then 10 times itself is 100. Again, if I didn't do the exponent first, notice that I'm going to get a different answer. So I always want to do exponents next. After we do exponents, next we're going to do multiplication or division before we add or subtract. So here, we're going to do multiplying first. So 5 times 3 becomes 15. And 15 plus 2 is 17. Down here, We can do addition first, and notice that we're going to get a different answer. 2 plus 5 is 7. That part returns us a 7. And then 7 times 3 is 21. So again, I always want to do multiplication first and then addition, and that way I can get the same answer. If I try doing it a different way, notice that the answer is going to change. So summarizing, one last thing. If we have multiplication and division on the same level, we just default left to right. So here, if I go from left to right, notice that this is going to be 30 divided by 5 is going to be 6, and then 6 times 3 is 18. If I tried going right to left, it's going to be different. 5 times 3 is 15, and 30 divided by 15 is 2. So if we have the same terms on the same level, such as multiplication and division, we're just going to default from left to right. So the shorthand for this, you might have heard of it before, is called PEMDAS. Please excuse my dear Aunt Sally. So we always start with parentheses first. After that, we're going to want to do the exponents next, then multiplication and division from left to right, and then addition and subtraction from left to right. So let's go and do some of these problems. So first, we're going to do multiplication first. So we're going to times this first. Again, I like copying and pasting the row before just to make it a little bit easier. So that's negative 7 times 4 is negative 28. All right, before I can add, I need to do the division next, right? Division becomes before addition, again, following PEMDAS. So 8 divided by 2 becomes 4. And then if I cancel out 28 reds and 4 yellows, those are going to cancel out to get negative 24. Okay. Here, again, I'm going to start off using the parentheses first. So I'm going to copy and paste that so I don't have to type it over and over. 3 plus 2 equals 5. Next in my rule is exponents. Notice that this has a little number in the corner. That's the exponent. Again, this is not 5 times 2. This is 5 times itself. 5 times itself is going to be 25. So let's change that to a 25. Okay. Before I subtract, I need to do multiplication. 25 times 6 is 150. And 150 minus 1 is 149. Okay. Here we have a few more. First, I'm going to do the parentheses first. So I'm going to copy and paste. 4 minus 5 becomes negative 1. Next, I'm going to do the exponent part. Notice that this is negative 1 times itself 3 times. So negative 1 times negative 1 times negative 1. That actually turns out to be itself. Turns back to negative 1. Okay. Before I can add, I need to multiply. That's next in my PEMDAS. I need to multiply. So 8 times negative 1 is negative 8 plus 3. And then 8 reds and 3 yellows. Those are going to cancel out to get minus 5. Okay. Here we have 2 parentheses, so I'm going to do the inner parentheses first. So negative 5 plus 3, that's going to be negative 2. Again, 5 reds cancel out with 3 yellows, makes 2 reds. All right, I'm still inside the parentheses, so let's do that next part next. Remember that when I have minus minus, I can turn that into a plus. So 4 plus 2 becomes 6. Change that to 6. And then negative 8 times 6 is going to be negative 48. All right, and the last problem. So here, let me copy and paste. The first thing we're going to do is going to do the exponent. So again, this is not 2 times 3. This is 2 repeated 3 times. So 2 times 2 times 2. 2 times 2 is 4, times another 2 is going to be 8. So again, 2 repeatedly multiplied. Now, and notice that we have division and multiplication all in a row. So again, we're going to default from left to right. So going from left to right, negative 16 divided by 8, that's going to be negative 2. From here, negative 2 times 8, that's going to be negative 16. And then 16 reds and 7 more reds, that's going to be 23 reds, negative 23. All right, we skipped this one. So what order should we perform these operations in? We're always going to follow a PEMDAS, right? We always start with parentheses, then exponents, multiplying, dividing from left to right, and adding, subtracting from left to right. Okay. Hopefully you found that helpful, and if you still have questions, please let me know.